Conjugates and division of complex numbers. Part 1. Complex conjugate. The complex conjugate, or just the conjugate, of the complex number z equals a plus bi is written as z with a bar on top of it and is given by the conjugate of z is equal to a minus bi, i.e. that is, we change the sign of the imaginary part of the complex number. Some examples of complex numbers and their conjugates are given below. So if z is equal to 3 plus 2i, then the conjugate of z is 3 minus 2i. If z is equal to minus 1 plus 5i, then the conjugate is minus 1 minus 5i. If z is equal to 4 minus I, then the conjugate is 4 plus I. If z is equal to plus 7i, then the conjugate is minus 7i. If z is equal to 6, then the conjugate is just 6. So it's very important that only the imaginary part changes sign. Complex conjugates. If z is equal to a plus bi, then the conjugate of z is equal to a minus bi, i.e. the conjugate is formed by changing the sign of the imaginary part. On an argon diagram, z is equal to a plus bi equals the point AB. So here we have the point AB, which is the complex number a plus bi. And the conjugate of z is equal to a minus bi, which is the point a minus b. So here we have the point a minus b, which is the conjugate of z, which is a minus bi. These are the images of each other under reflection in the real axis. So the real axis is like a mirror line. Complex numbers and their conjugates satisfy some interesting and important properties. Properties of conjugates. If z is equal to a plus bi, then, property 1, z plus the conjugate of z is equal to twice the real parts, which is equal to 2 times a. Property 2, z minus the conjugate of z is equal to twice the imaginary parts, which is equal to 2 times bi. Property 3, z times z, that should actually say have a bar on top of it. So it's z multiplied by its conjugate is equal to a squared plus b squared, i.e. the product of a complex number and its conjugate is always a non-negative real number with no I. So we take the real number, we square it, we take the imaginary number, we square it, and we add them. To demonstrate these properties, z plus the conjugate of z is going to be a plus bi plus a minus bi. So we'll have a plus a gives us 2a, and bi minus bi will cancel. So since a represents the real part, it's 2 times the real part. Property 2, z minus the conjugate of z will be a plus bi minus a minus bi. A minus a will cancel, and we're left with bi minus minus bi, which is bi plus bi, which is 2bi. So you end up with 2 times the b, which is the imaginary part. And property 3, which is the most important and is going to help us a lot in later questions, is z multiplied by the conjugate of z will be a plus bi times a minus bi, which will give us a times a minus bi plus bi times a minus bi, which will give us a squared minus abi plus abi minus b squared I squared. Minus abi, positive abi cancel. The I squared becomes minus 1 with brackets around it. And minus b squared times minus 1 is positive b squared. So we get a squared times b squared. This is really important and we're going to use it a lot later on. Example. If z is equal to 1 plus 2i, evaluate z multiplied by the conjugate of z plus 4 times z plus the conjugate of z. So if z equals 1 plus 2i, then the conjugate of z is 1 minus 2i. So z times the conjugate of z will be 1 plus 2i multiplied by 1 minus 2i. Then we're going to add on 4 with large brackets or square brackets. And we're going to have z, which is 1 plus 2i, plus the conjugate of z, which is 1 minus 2i. So multiplying out the brackets, 1 times 1 is 1, 1 times minus 2i is minus 2i, 2i times 1 is 2i, and 2i by minus 2i is minus 4i squared. We still have the plus 4 and the brackets. Then we're going to add the real parts with the real parts. 1 plus 1 makes 2. And the imaginary parts with the imaginary parts. Plus 2i minus 2i will cancel. Minus 2i plus 2i will cancel over here as well. We bring down the 1. The I squared becomes minus 1 with brackets around it. We bring down the plus 4 and the 2. So we have 1 minus 4 by minus 1 is plus 4, and we still have the 4 times 2. Now at this point we can jump down to the last line. 1 plus 4 is 5, 4 times 2 is 8, and 5 plus 8 is 13, which is a real number. But we could have actually skipped all this rough work and used the fact that we know that multiplying a complex number by its conjugate, we just square the real part and the imaginary part and add them. So 1 squared gives me 1, and 2 squared gives me 4, and 1 plus 4 is 5. Part 2, division. Dividing a complex number by a real number is easy. For example, 12 plus 7i divided by 4. We divide the real part by 4, 12 divided by 4, which is 3. We divide the imaginary part by 4, 7 divided by 4 just stays as 7 over 4i. However, to divide a complex number by a non-real complex number, i.e., if there is an I on the bottom line of the fraction, we must multiply above and below by the conjugate of the bottom line, or by the conjugate of the denominator. The effect of this is to convert the bottom line into a real number using property 3 of conjugates. Example 3 shows how this is achieved. If z equals 9 minus 7i and w equals 1 minus 3i, express z over w, or z divided by w, in the form of a plus bi, where I squared is equal to minus 1. So z divided by w will be 9 minus 7i divided by 1 minus 3i. The bottom line or denominator is 1 minus 3i, and its conjugate is 1 plus 3i. This is what we multiply above and below by. So multiplying the top, we have 9 minus 7i multiplied by 1 plus 3i. So we're going to have 9 minus 7i with brackets, and then 1 plus 3i with brackets. And then multiplying the bottom, we have 1 minus 3i multiplied by 1 plus 3i, which will be 1 minus 3i in brackets, stuck onto 1 plus 3i in brackets. So multiplying out the top, 9 times 1 is 9. 9 times 3i is plus 27i. 7i times 1 is minus 7i. And minus 7i times plus 3i is minus 21i squared. And multiplying out the bottom, well, we can multiply it out the long way by cracking open the egg and so on. Or we can use our formula that we take the real part, the a, which is 1, and we square it. And we add on the imaginary part, squared, which is minus 3, and minus 3 squared. So we have 1 squared plus minus 3 squared. Then simplifying the top, we have 9 plus 27i minus 7i gives us plus 20i. The I squared gives us minus 1, and minus 1 times minus 21 is plus 21. And then the bottom, 1 squared gives us 1, minus 3 squared gives us 9, and 1 plus 9 is 10. Then 9 plus 21 is 30, so we have 30 plus 20i over 10. So then 30 divided by 10 is 3, and 20i divided by 10 is 2i.